what we're going to do is we're going to charge this object, and when we have these set up, first we have a neutral ball and a neutral rod. And if you look at this diagram up here, this is how we've drawn the charges. You can see there's an equal number of protons and electrons in each item, so they're both neutral. In the lab it says first, bring this close to here, does anything happen? Nothing happens. And we know that these don't have a charge, so that's why. The lab says to charge an item and bring it to the side of the rod, and that when you bring it to the side of the rod, you watch what reaction happens here. So let's charge this up. I've got a balloon with, I think it's a nylon rug. And the balloon has a stronger hold on electrons. It's a good insulator, so it should take electrons from the rug through the friction that I'm doing here. And watch the ball. It appears to be attracted to the rod. Oh, and then it even touched. Now, why was it attracted? Well, let's take a look at the board over here. We have a balloon that has a collection of electrons on one side, which we stole from the nylon. The rod has the same number of protons and electrons still, because nothing has touched it, and it's sitting on a piece of rubber, so it's not grounded. But all the electrons seem to go to one side, and that's because we know that like charges repel. These electrons are repelling the electrons in the copper to the other side. This is where a student says, well, why can they move freely? Because we know that they stay in one place here. Well, this is an insulator. Static happens on an insulator because electrons cannot move on their surface. This is a conductor. And in a conductor, electrons can freely move wherever they wish. So they were repelled to the other side. Then the ball was attracted. The third thing the lab says, it says do the experiment again, but it wants me to touch my finger to the other side of the rod. Now if you move the camera here, we'll get a good angle. So I'm going to charge the balloon. Oh, I want to make sure that it's neutral. I'm going to charge the balloon. And when I think it has a good charge, I'll hold it close and touch my finger. There was a tiny snapping sound, and I think I got a shot. When we hold the ball to it now, there should be a slight reaction. Oh, once again, it's attracted to the copper. And then when it touches, it starts to repel from the copper. Here's what's happening. If we go to the board, we had the ball away. I had once again used a charged object to repel all the electrons to one side. I touched my finger and I stole the electrons. They grounded through my body and into the earth. That left the rod positively charged. Now because this is positive and the ball is neutral, they are attracted because they are unlike charges. Then at one point the ball touched. And when it touched, some of the electrons jumped in to the copper rod and probably spread throughout. But you can see that the positive still outweighs the negative. There's more protons than electrons, so it's positively charged. There's more protons here than electrons. They are both positive, and so they repel, because like charges repel. Let's look at our key words here. Here's what happened. We had unlike charges repelling. Whenever the protons outnumbered the electrons, there was a positive charge. When the electrons outnumbered the protons, there was a negative charge. We saw repel when things were the same. We used copper, which is a conductor. We used insulators, which were the balloon. If you use these words in your explanations, you should be able to explain this experiment. Thank you.